The first very important thing to understand about the large language model space are what we call scaling laws. It turns out that the performance of these large language models in terms of the accuracy of the next word prediction task is a remarkably smooth, well-behaved, and predictable function of only two variables. You need to know n, the number of parameters in the network, and d, the amount of text that you're going to train on. Given only these two numbers, we can predict to a remarkable accuracy, with a remarkable confidence, what accuracy you're going to achieve on your next word prediction task. And what's remarkable about this is that these trends do not seem to show signs of sort of topping out. So if you train a bigger model on more text, we have a lot of confidence that the next word prediction task will improve. So algorithmic progress is not necessary. It's a very nice bonus, but we can sort of get more powerful models for free because we can just get a bigger computer, which we can say with some confidence we're going to get, and we can just train a bigger model for longer. And we are very confident we're going to get a better result. Now, of course, in practice, we don't actually care about the next word prediction accuracy, but empirically what we see is that this accuracy is correlated to a lot of evaluations that we actually do care about. So, for example, you can administer a lot of different tests to these large language models, and you see that if you train a bigger model for longer, for example, going from 3.5 to 4 in the GPT series, all of these tests improve in accuracy. And so as we train bigger models and more data, we just expect almost for free the performance to rise up. And so this is what's fundamentally driving the gold rush that we see today in computing, where everyone is just trying to get a bigger GPU cluster, get a lot more data, because there's a lot of confidence that you're doing that with, that you're going to obtain a better model. And algorithmic progress is kind of like a nice bonus, and a lot of these organizations invest a lot into it. But fundamentally, the scaling kind of offers one guaranteed path to success. So I would now like to talk through some capabilities of these language models and how they're evolving over time. And instead of speaking in abstract terms, I'd like to work with a concrete example that we can sort of step through. So I went to ChatGPT and I gave the following query. I said, collect information about Scale AI and its funding rounds, when they happened, the date, the amount, and the valuation, and organize this into a table. Now, ChatGPT understands, based on a lot of the data that we've collected, and we sort of taught it in the fine-tuning stage, that in these kinds of queries, it is not to answer directly as a language model by itself, but it is to use tools that help it perform the task.